Bismillahirrahmanirrahim. Assalamualaikum and a very good day to you all. In this video, we're going to talk about thick film lubrication from the book Shigley Mechanical Engineering Design. Okay, let's continue. Okay, this is the wedge shape. Okay, this is the wedge. Now suppose the lubricant is reduced and the top of the bearing is shown in figure. Okay, the action of the rotating journal is to pump the lubricant around the bearing in clockwise direction. Okay, so uh, what is the meaning by wedge shape? Okay, the wedge shape is like this. This is the force. This is the force. When you give the force is become like a wedge shape, going like that. Okay, you can Google what is the image of a wedge. It's more like this. Okay, the force going like that. If the journal going up, the force will become up like that. Okay, the same goes to left, right, or bottom, everything. See, so this is the wedge direction. Okay, rotating journal. Okay, figure 25 shows how to decide whether the journal under hydrodynamic lubrication or in centric location, located on the right or on the left side. Visualize journal beginning to rotate. Find the side of the bearing upon which the journal tends to rotate, and then with lubrication in hydrodynamic, mentally place journal to the opposite side. So like this. This is the journal being rotated. Okay. This is dry, meaning that the journal with gravity will go down. Okay, of course. Then when the journal is being full, we pull, then it become hydrodynamic. And remember, what is the definition of hydrodynamic? Hydrodynamic can be loosely translated as full of lubricant. This is full of lubricant. So you go, okay, and then it will become full of lubricant, and then the lubricant oil fills the bushing. Okay, nomenclature of a journal bearing. Figure in 12.6 in the next slide. Okay, this uh, this slide want to tell about the eccentricity, meaning that according to Petrov equation, there is a video on Petrov equation. Petrov equation says that assume that the journal is in eccentric with the bushing. Okay, the coordinates of the bushing and coordinates of the journal, the 0, 0 position is coeccentric, meaning that is the same journal, the same location. Of course, in real in for to make an equation, we assume like that. It is easy like that. In reality, the when no lubrication or when with lubrication, the gravity, the weight of the journal itself will make this journal going down, and then the center location is not the same. Then the difference is concentricity. The difference between the center position is called as concentricity. Okay, so given by this equation, C is the clearance, E is eccentricity, E is eccentricity. Okay, so nomenclature of journal bearing, you can see here, C is the radial clearance. Okay, N is the speed of the journal. Okay, and this is the journal. This is the position of the O is position center location of bushing, and O naught is center location of the journal, and then the difference is E. Okay, and this beta is the angle. Okay, in this picture it can be called as partial bearing 120 degrees. This is H naught. H naught is the minimum film thickness. Okay, what is a minimum film thickness? H naught. Okay, you will see again the H naught in when we are doing comparison. Okay, H naught is the minimum film thickness, meaning that imagine this, the hole is full of lubricant, whether it is oil, whether it is grease. Okay, and then when this journal is at the bottom of the lubricant, is the bottom of the base of the bushing with the lubricant inside it, there is a gap because of the lubricant. This gap is in 0.000 millimeter, meaning that maybe you cannot see with your eye. Maybe we cannot see with your eye, but theoretically there is a lubricant preventing metal to metal contact. Okay, even if it is 0.0001 millimeter, is also is a gap, H naught. Okay, bearing classification. This is a partial bearing. This is the full bearing. There is a fitted bearing. Okay, what is the difference? Okay, partial bearing shown in the figure. The bearing shown in the figure is known as partial bearing in the previous slide. Now from Google, I taken some image. This image from Google showing the difference between full bearing, partial bearing, and fitted bearing. Okay, if the radius, if the bushing is the same as the radius original, it is known as fitted bearing. Okay, radius of bushing is the same as radius original, it is known as fitted bearing. This is called the fitted bearing, meaning that uh, the it is fit. Okay, uh, it is fit. Maybe there is lubricant, maybe there is not lubricant, but it is fit. Okay, it's fit inside the journal is fit inside the bushing. Theoretically, no gap. Okay, and then this is the partial bearing. Okay, this is the bushing encloses the journal as indicated in dash line. It become full bearing. Okay, when the angle in contact of bearing of the journal is 360 degrees, the journal is called full bearing journal, meaning that eventually the journal will become full of lubricant because of this action. Okay, you see here the journal. Okay, after a while, when you are pouring the lubricant, the the lubricant is not full yet, and when it is not full yet, it is called partial bearing. And when eventually it become full of lubricant, it become full bearing. Okay, it become full bearing. Okay, so we will meet this term again in the next video when we are doing the example. Okay, so that's all for this video. We see you in the next video on hydrodynamic theory. Okay, thank you very much.